we have one more formula to talk about, and that's the EMF or voltage induced in a current carrying wire that is moving through a magnetic field. In this formula, we have EMF, E, cursive E, B is the magnetic field in Tesla, L is the length of the wire in meters, and V is the velocity of the wire. So again, oops, let's get my pen working here. E is EMF, which is in volts. It's the same thing as voltage. B is the magnetic field. That's measured in Tesla. L is the length of the wire, measured in meters. And V is the velocity of that wire, measured in meters per second. Let's take a look at a sample problem. Oops, there it is. Calculate the speed needed to induce a voltage of 5 volts in a 10 centimeter long wire and a 2 Tesla magnetic field. Now, let me talk a little bit about what's actually happening in this situation. Here we have wires, a resistor, more wires, and then usually a metal bar that is movable. Finally, we have an external magnetic field. What happens is when we move this metal bar across the wires in the magnetic field, when we move the bar in the magnetic field, what will happen is a voltage will be induced and a current will be induced in the wire. Now, this current will be opposite in such a way that it will take work to move this metal bar across the 2 wires. And ultimately, that work that we do goes into inducing a current in this circuit. And this is the primary idea behind a generator. If you can move a coil in a magnetic field, you can induce a current. So let's go ahead and solve this. We have that, let me grab my pen, a moment. We have that EMF or voltage equals the magnetic field times the length of the wire times the velocity. So we want a 5-volt EMF. We have a 2 Tesla magnetic field induced by this magnet down here. The length of the wire is 0.1 meters. And we want to know the velocity with which we need to move this metal bar. We want to know the velocity with which we need to move this metal bar in order to induce this 5 volts across the resistor. So now it's just a matter of solving the equation. We have 5 equals 0.2 V, and when we divide, we'll get that the velocity is 25 meters per second. That's pretty fast. We could expand on this problem. We could find, say, the power in a 5 ohm resistor. So let's say we can move the metal bar at 25 meters per second, and let's say that this is a 5 ohm resistor, and remember that we just induced 5 volts of EMF through that resistor. What's the power? We have a couple of different ways to go here. We could say that power is equal to current times voltage. We have a current. Oh, we don't know the current, do we? So let's go ahead and use a different formula. Let's use voltage squared over R, because those are the things that we have. So voltage squared would be 5 squared. And The resistor is 5 ohms. So 25 divided by 5 is just going to be 5 watts of power developed in this resistor simply by dragging this metal bar across the two wires in a magnetic field, an external magnetic field.